to another fun-filled adventure in math with Mr. Sims. This is algebra. We're talking about long division of polynomials today, which scares a lot of people, but it really shouldn't. It's just as fun as it sounds. So what we're going to do today is we are going to tackle long division of polynomials. Now, you might remember long division from when you were in probably 5th and 4th grade here. So let me just go ahead and do like a quick long division problem. Let's say I had well, let's just say I had 827, and I wanted to take and divide that by, let's say 3, right? Well, 3 goes in, if you remember, 3 goes into 8, a total of 2 times 3 is 6, subtract, I get 2, right? Then I bring down the 2, 3 goes into 22, 7 times, 3 times 7 is 21, right? And now I end up with 1, and I bring down the 7. And you'll probably remember this process that you did, where you divide into, you get the number, then you multiply, and then you subtract, and so you do this over and over, and then you bring down, and so you do this basically until you get to the end here. Here I'm going to bring down my 7. I go 3 goes into 17 5 times, right? 5 times 3 is 15. I subtract, and I get 2, and 2 is my remainder. And if you remember correctly, what I did with that remainder, there were multiple options. I could leave it a remainder, right? You put the r, just 2, right? R is 2, and you might remember that. That was one way to do it. The other way to do it was you actually put a decimal point, and you put a 0, and you bring down the 0, and you continue ad infinitum until it basically doesn't repeat anymore. Or the other option was you take this 2 and you realize that the 2 has yet to be divided by that 3, and you would take and just put it 2 over 3 like that, right? And that's actually the way that we're going to use it today as we're doing the long division of polynomials. Should that occur, we're going to turn it into a fraction, okay? So anyway, I just wanted to review that concept with you so that we can actually get into long division of polynomials. And basically what I want you to understand is long division of polynomials is basically just the opposite of when we take and what's the word I'm looking for? When we take and a factor, like when we do FOIL, basically the long division of polynomials is kind of the opposite of it, right? So for instance, this is our first problem here: 18x squared plus 27x plus 10, right? So I get 3x plus 2. So I'm going to actually show you later on that basically we can check our answer actually by doing FOIL. But anyway, I just wanted you to understand that long division of polynomials, that's what it is. Basically, it's just the opposite of FOIL, okay? Or opposite of any type of rainbow method, because FOIL really is only for two binomials. So really it's the opposite of not just FOIL, but the whole rainbow method. Whenever you have like any number of terms, right, being multiplied, like let's say I had x plus 3 and I'd had x squared plus x plus 7, right? Remember, at this point it wouldn't just be FOIL, because I actually have to do that times that times that times that. Everything has to be multiplied times every other term. So in that case, it's not just FOIL, it's more than FOIL. So we call it the rainbow method or whatever. But anyway, I just wanted you to understand long division is the opposite of doing this. So let's go ahead and without further ado get on to some of the fun stuff here. So I'm just going to get rid of that off my screen because that annoys me. Alright, so here we go. Let me zoom in just a hair. Oh, that wasn't good. Let me zoom in just a hair and we can get started. So the first thing I'm going to do, if I have a problem like this, I'm actually going to take my problem and I'm going to set up normal division. What I'm going to do is I'm going to take my 18x squared, I'm going to put that underneath, just like I do with the regular thing. It's going to become my dividend. Okay, 18x squared plus 27x, right? Plus 10. And you'll notice that I did line them up in order. In other words, I lined them up in order by degree of the x term. The degree of the x term is basically just talking about the exponent right here. See, this is my biggest exponent, is second degree exponent. Here's the first degree exponent because there's an understood 1 there, right? And then finally, this one has x, really you can think of it like x to the 0 degree, right? Where you have 0x here, but we don't write that, we just leave it as a constant, right? So in this case here, I've written them, remember, in in descending order by degree. So x squared, the x and the 0, the x to the 0 term here. And then on this side here, I'm going to write what am I dividing by. So this is actually going to go into, whoops, this is actually going to go into here, where I make it 3x plus 2. And now we start this whole division process. Now, just like you did with regular division, like we did over here with regular division, you started by asking how many times does 3 go into 8. I'm going to do the same thing here, and I'm going to focus on this first term here and this first term here. So I'm asking how many times does 3x go into 18x squared? So if I'm looking at that, I say, okay, well, my 3, to get my 3 to 18, I have to get a 6, right? I need a 6 as a coefficient here. So 3, because 3 times 6 would be 18, right? But also, or 18 divided by 3 is 6. But also, notice that I have x squared here, and here I have x. So what I need to do is I need to take that, and I need to get something to turn this from 3x to x squared, right? In order from x to x squared. So I'm going to need an extra x there. In other words, now if I multiply 6x times 3x, I'm going to get 18x squared. And in fact, I'm going to do that right now. I'm going to multiply 6x times 3x, and that's going to give me 18, as I said, x squared, right? And that's looking pretty good. But notice that this is not, 3x is not my complete divisor. My complete divisor is actually 3x plus 2. So I do have to deal with this plus 2 here. And the way I deal with that is by also multiplying this 6x times the 2. So when I do that, I get 6x times 2, which is plus 12x. And now I'm going to go ahead and take that, and I'm going to subtract those. 18x squared minus 18x squared obviously is 0, right? 27x minus 12x is not going to be 0. In fact, we're going to get 15x. So I end up with 15x, and then I bring down. This is the bring down step. After you do this subtraction, right? You bring down, and I get plus 10, right? So now I have 15x plus 10, and once again, I'm going to start that whole process over again. I'm going to say how many times does 3x go into 15x, and you'll notice 3x goes into 15x. How many times? 3x goes into 15x, a total of 5 times, right? And I'd ask you right now, do I need an x? Well, let's look. This is 3x. If I put an x here, 5x times 3x won't be 15x, it'll be 15x squared. So I don't want to put an x here this time because 5 times 3x gives me the 15x I'm looking for. So 5 times 3x is 15x, right? I'm going to subtract that, but before I do that, I'm going to do 5 times 2 as well, which gives me a plus 10. And this one turned out really pretty for us. Basically, when we subtract all that, I get 0 here, and I get 0 here. So basically, I have 0 as a remainder. I don't need to do this 0. The whole point is, when I was done, I got 0 as a remainder. And so my answer is 6x plus 5. And you don't actually ever have to wonder if you got this right. What I could do now is I could actually do the opposite. And I know how to do the opposite. I would take my 6x plus 5, and I would actually multiply it times my 3x plus 2. Okay, and in this case here, 6x times 3x obviously is 18x squared, right? I did that step, right? Now I'm going to do this step. 6x times 2 is going to be plus 12x, right? Then I'm going to do 5 times 3x is going to be plus 15x. And then 5 times 2 is plus 10, right? And when I add all of that puppy together, I get 18x squared plus 27x plus 10. And that ended up giving me the same answer. And because it gave me the same answer, I know I'm right. So that's my check. Yay! And we can give ourselves a good smiley face. Yay! With one eyeball. Why not? All right, so now you have a good start to that. That's your first problem. Hopefully you were successful on that. If you want to redo that now, you could pause the video and just try it again yourself. Make sure you can get that answer all by yourself. Otherwise, I'm going to move on. So in this case here, let's move on to the next problem. I have 6x plus 27x plus 30, all divided by 2x plus 5. So once again, I'm going to set up my problem. Underneath the division sign, I'm going to get 6x squared plus 27x, right? Plus 27x plus 30, right? And all of that's going to be divided by 2x plus 5, okay? And if you're looking at that right now, hopefully that's not looking really scary at this point. It shouldn't be too bad for you. So I'm actually going to take this 2x. I'm going to see what do I do to 2x to get 6x squared. And you can go ahead and pause. I think you know how to do this problem at this point. So go ahead and pause the video and give it a shot. Seriously, pause the video and give it a shot. Did you pause the video and give it a shot? If you didn't, do it now. All right, hopefully you actually did pause the video and give it a shot. That's important. Remember, if you're not actually trying the problems, you're not learning. So if you don't have a piece of paper and pen handy right now, go get that piece of paper and pen, because you really, really, really need to be actually doing these problems. Watching the video without doing the problems is really kind of pointless. I'm just going to be straight with you. You need to be doing the problems, otherwise you're not learning. You need to do the repetition so that your brain learns it. So anyway, 2x goes into 6x squared, a total of 3x times, and that's because 3x times 2, 3 times 2 is going to give me a 6, x times x is going to give me x squared, so that's going to get 6x squared just by multiplying those two together. But I also have to multiply my 3x times my 5, and by doing that I get plus 15x, right? Now I'm going to go ahead and subtract, and I end up with these cancel out. 6x squared minus 6x squared is 0, and 27x plus 15x, minus a positive 15x is actually going to be 12x, right? Yeah, that looks right. So 12x, and then I'm going to bring down the 30 here. I ask myself the question again, how many times does 2x go into 12x? And the answer to that is actually 6x, right? 2x goes into 12x. Not 6x. Whoa, I almost made a mistake there. 6 times, thank you. 6 times 2x is 12x, right? And then 6 times 5 is plus 30. And I get, I bring this down and I subtract and I get 0 as my remainder. So my answer is 3x plus 6, right? So 2x plus 5. If I wanted to actually check it, once again, I would do this to check it. 3x plus 6 times 2x plus 5. And I do encourage you to do that. I'm not going to do it in the interest of time tonight, but if you want to try it to see, you can pause the video and give it a shot and see if you get 6x squared plus 27x plus 30. If you don't, then either you did this wrong or you did this wrong, which means I did this wrong too. So hopefully I didn't do that wrong, but you get the idea. All right, so let's move on to our next problem. If you wanted to pause and do that, go ahead and do that now before we move on. All right, moving on to the next problem. So now notice that they just wrote it a little differently. We don't have it separated by the division sign here. So instead I have this division sign. So I'm going to take, once again though, remember this is the one you're dividing, and you're dividing it by this divisor because the one that you're dividing comes before the division sign, right? So I get 2x squared minus 17x minus 38. I'm going to take and divide that all by 2x plus 3. And so what I'm going to do here is I asked the question, how many times does 2x go into 2x squared? And the answer is it goes in x times, right? X times 2x is going to give me 2x squared. So I get x times 2x is 2x squared, but I also have to multiply my x times my 3, which gives me a positive 3x. So I subtract that and I get negative 17x plus 3x is negative 14x, right? Then I'm going to subtract 38 from that, right? I'm going to just bring down my 38. And I now ask the question, how many times does 2x go into negative 14x? And the answer is, to get negative 14x, I would actually have to multiply it by a negative 7, right? Negative 7 times 2x would be negative 14x, right? And I'm going to multiply also that negative 7 times 3, which is going to be minus 21, right? Now I'm going to subtract all that, right? Now notice I'm doing 14x minus 14x minus a negative 14x minus a negative 14x, so those are going to cancel out, and I get negative 38 minus a negative 21. Well, if you have a negative 38 and you subtract a negative 21 from it, you're actually adding 21, right? So in this case here, I have 38 essentially plus 21, and 38 plus 21. If you do it, you get, let's see, 38 plus 21. My brain just stopped working on me. It is, oh, sorry, negative 38. Negative 38 plus 21 is a total of negative 17. Where did I make a mistake here? Hold on a sec. Mr. Sims made a boo-boo, and he's trying to find it. 1 second here. X minus... Uh-oh, Mr. Sims, Mr. Sims, Mr. Sims, Mr. Sims, Mr. Sims. So, in this case here, where did I make the boo-boo? I've made a mistake somewhere. So hold on, let me backtrack and see where I made that mistake. So I have 2x squared. 2x goes into here. X times 2x is negative 2x squared. Then I did x times 3 is plus 3x, right? And I got this. This is a negative, minus. That's where I made a mistake. Oh my gosh, Mr. Sims almost made a big boo-boo. So look there. What I have a negative 17 minus a 3x. So that's not actually going to cancel out. That's actually going to be a negative 20x. Whew. That was almost really bad, so I'm glad I caught myself right there. Hey, is it easy to make mistakes? You bet you it is. So negative 20x minus 38. I do bring down that minus 38. Okay, now, haha. So that went, so 2x goes into negative 20x minus 10 times. There we go. Minus 10 times. So negative 10 times a 2x is a negative 20x, right? Negative 10 times 3 is minus 30, right? Now I'm going to subtract all of that, and I end up getting, these cancel out, but negative 38 minus a negative 30 is going to be a negative 8. Okay? It's going to be a negative 8. And so that's my remainder here. But if you remember earlier when we did regular division, right, we realized that, hey, if you have a remainder, you still need to divide it by your divisor. And so what I'm going to do is I'm actually going to go do that over here. I'm going to take this negative 8, and I'm going to take this negative 8 and divide it by my 2x plus 3. So my answer then becomes minus 8 over 2x plus 3. Okay? All right, so once again, do be careful when you're doing your subtraction. You remember, this is a subtraction sign, so it's easy. It's very easy to make that mistake like I just did there. I'm glad I caught it before I published the video, right? But that's basically how easy it is to make a mistake, because you're doing, sometimes you're doing subtraction of negatives, which is positive, and sometimes you're subtracting a positive. It just gets confusing a little bit. So just watch out for your subtraction sign to make sure you get that right. All right, moving on to the next problem. And hopefully that made sense to you of how we got this. Once again, we put this negative 8 over our divisor, just like you did the regular fractions earlier, okay? So let's go ahead and do the next problem now, which is over here. Yeah, this one's going to be fun. So, all right. So this problem here is a little bit more difficult. Now, I don't want you to pause and do it by yourself right now. I want you to actually just listen to me for a second, because the problem with this one here is we are missing some degrees in between. In other words, we have 42x squared, but notice that we're missing the x to the 1 term, right? We're missing just the regular x term. So if I were doing this division problem here, what I have to do is I have to account for the x to the 1 term. And the way I do that is after I write my, my division symbol here. Let's see. And let's see. That's ugly. Let's not do that. Okay. So after I do my regular division sign here, I really don't like the way that turned out. There we go. Then I need to account for the x to the 1 term, right? I have the x to the 2 term, but I need to account for the x to the 1 term when I'm doing long division. And the way I'm going to do that is I'm going to add to that 0x to the first power, or 0x, right? I'm just going to put that in because it's missing right now. Now, I have my negative 33, so I'm going to take and make that minus 33. Now, once again, I just want to reiterate why I put the 0x, because when I'm doing the division of polynomials, I need to have all my degrees. I can't have any degrees missing, right? So this is x to the 2 power, so this is to the second degree. This is to the first degree, right? And this is, remember, x to the 0 degree, which is anything to the 0 power is 1, so that just becomes 1, right? It just becomes 1, and because it becomes 1, I can just leave it as 33, right? And so I just need to have all my degrees from 2 down to 0. So now that I have that, I can actually do the division. I can actually do 7x as my divisor, 7x plus 7. And I'm going to ask the question, how many times does 7x go into 42x squared? And I get 6 times 7 is 42. And notice, though, that only gives me 42. I need another thing to get me my x squared. So I have to actually put an x there because I need 6x to give me my 42x squared after I multiply it by 7x. So 42x squared, because 6 times 7 is 42, x times x is x squared. And now I'm going to subtract those, but before I subtract those, I need to also multiply this 6x times my 7. So 6 times 7 is 42x. So I get plus 42x. And now I got to be extremely careful as I do this next step. So what I'm going to do is I'm actually going to take my my 0x, I'm going to subtract from it 42x. These cancel out. 42x squared minus 42x squared is 0. But 0x minus my 42x is going to be a negative 42x. And I'm going to take from that and bring down my negative 33. Okay? After I finish that step. So negative 42x minus 33 now, right? And now I'm going to do that whole process again, where I ask how many times does 7x go into? Negative 42x, and in this case it goes in to it a negative 6 times. And this is where a lot of people mess up. They mess up with the negatives here. So the negatives are really important to be careful of. Whenever you have to work with negatives, just be extremely vigilant. Make sure you get them right. So in this case, negative 6 times 7 is going to give me that negative 42x. And I don't need another x because I already have an x here. And this is only x to the first degree. So I'm going to take and make it negative 42x and subtract negative 42x. But I also have to multiply that negative 6 times 7. So that's going to be negative 42. Now I have negative 42x minus, sorry, this is minus a negative 42x is going to cancel out. Negative 33 minus a negative 42, though, is actually going to be negative 33 plus 42. So that's actually going to give me 9 as a remainder, right? It's going to give me 9 as a remainder. So that 9 now, if you remember that 9, right, is still needs to be divided by 7x plus 7. So I'm going to add to this 9 over 7x plus 7. Now, just so you know, let's say I didn't put it over this and I just left it a remainder of 9. If I were going to check this at this point, what I would need to do is actually take my 7x plus 7 and my 6x minus 6, right? And I would have to multiply these before I added my 9, right? Make sense? So in this case here, if I multiply, if I actually multiply it out, I get 42x squared, right? Then I get minus 42x, right? Then I get plus 42x, right? And then I get minus 42. And when I do that, I get 42x squared minus 42, right? But you'll notice this isn't what I originally started with. I started with 42x squared minus 33. So now that I finished that whole FOIL process, now I need to add my plus 9. And by adding my plus 9, right, combining these like terms here, I get 42x squared minus 33, right? But I wanted to show you that that's how that works, right? That's how that works if you were to leave this just kind of a remainder, right? But if you turn it into a fraction, then that actually gets factored in with the whole polynomial. That 9 over 7x plus 7 actually gets put inside this parentheses, right? So that's why we actually want to do it. We actually want to turn that 9 into plus 9 over 7x plus 7. And when you do that, what ends up happening is that 9 plus 7x plus 7 now actually goes inside the parentheses. Instead of being outside, it's no longer outside. It actually becomes a part of inside the parentheses. And then when you multiply that, anyway, anyway. Basically, you always want to put the remainder over the divisor. So there you go. I just wanted you to understand kind of how that plays out. If you were trying to check yourself, you would need to leave that plus 9 till the end and then incorporate if you want to check yourself with the remainder, okay? So anyway, all right, moving on to the next problem. If that confused you, don't worry. Just remember, always put the remainder over your divisor when you're done, and you're good. So all right, and now I'm going to do this step here. I'm going to take and and that dot's really going to bother me, but that's okay. I'm just going to roll with it. So I'm going to take and I don't want this color anymore. I want a different color. I want blue. Yes, I want blue. Oh, that's a beautiful blue. All right, so here we go. So I have x squared plus 3x minus 44. And I'm going to divide this now by x minus 6. And you can actually probably do this one now by yourself. Go ahead and give it a shot. Pause the video and let's see what you get. All right, hopefully you actually did pause the video and actually gave it a try. If you always want to see me do it first and then try it yourself, that's not a terrible way to do it either. But it's better to be able to do it by yourself without me interfering in any way, okay? So in this case here, I'm going to take my x. I'm going to say, how many times do I multiply x to get x squared? And so you'll notice I only have to multiply that times x. X times x is going to give me the x squared that I'm looking for. And then I have to also multiply, remember my x times my negative 6, which is going to be negative 6x, right? I'm going to go ahead and subtract those now. And I get x squared minus 6x squared cancels out, but 3x minus a negative 6x is actually going to be a positive 9x, yeah? And I know that's confusing still, then minus negatives and stuff like that, but you'll get used to it the more you do it. And then I'm going to bring down my negative 44, right? And when I bring down my negative 44, I should... let's see, I asked myself the question again, how many times does x go into 9x? And the answer is it goes in a plus 9 times. 9 times x is, in fact, 9x, right? 9 times negative 6. 6 times 9 is 54. So that's going to be actually a negative 54 because it's a negative 6 times 9. So in this case here, I end up with, when I subtract everything, I end up with... negative 9x minus a 9x is 0, and then negative 44 minus a negative 54 is actually going to be a positive 10, right? So I'm going to end up with a remainder of 10. Now, I already have my x plus 9, and this remainder of 10 has yet to be divided by my x minus 6. So I'm going to go ahead and take and add and put my 10 over x minus 6 here. And that right there is my final answer, x plus 9 plus 10 over x minus 6. Okay? And hopefully you're doing good still. All right? Hopefully you got that answer all by yourself. We are going to get to some difficult problems coming up here soon, so just buckle up. We got it. Just keep with me, and we're going to make you a master at this, okay? So this one here, let's look at this problem here. This problem here, now we got a third degree polynomial, just because why not, right? And so I'm just going to take my 27x cubed, just like I've been doing, right? It doesn't matter that this is a scary looking third degree term. You can take and just make it a beautiful, beautiful thing by just putting under the division bar and just doing what you normally do. In fact, why don't you go ahead and give it a shot? You know what? Intimidation, the only way to face your fears is to just do it, right? So let's just do it. Go ahead. Knock it out, right? Pause the video, try it. Come on. Fortune favors the bold. Go for it. You know you want to do it. All right, hopefully you actually did try it. So if you did try it, you got, let me see. 3x goes into 27x squared. So to get 3 to 27, I go 3 times 9, right, is 27. 3 times 9 is 27. I get, but I need to get x cubed is the problem. So to get x cubed, I have to ask myself, what do I do to get x cubed? Notice I only have x right now. So I actually need x squared now. If you've just been used to putting x each time, you might have done that, but I need an x squared term to get my x cubed term. So I get 9x squared times 3x is going to give me 27x cubed, right? And I'm going to take now, and I have to also multiply my 9x squared times my negative 2. So this is starting to get pretty scary pretty fast, right? But just bear with me. The more you do it, the better you get, right? So 9x squared times a negative 2 is going to be a negative 18x squared, right? Now I'm going to subtract both of those. And these cancel out. 27x cubed minus 27x cubed cancel out. They won't always, but in this case they do. And this I have 9x squared minus an 18x squared. It's not a 9 squared minus an 18x squared. It's a 9x squared minus a negative 18x squared. So in fact, they get added in this case. So 18 plus 9 is going to be 27x squared, right? I think I did that math right. So 27x squared. I guess I'll find out real soon. And then I'm going to bring down my negative 3x term. Okay, so far I think I'm looking pretty good. I get my 3x. Now I'm going to say how many times does 3x go into 27x squared? And I realize that 3x goes into 27x squared. A total of 9 times. 3 times 9 is 27, right? But to get the x squared term, I need to make it an x as well, right? So I get 9x times 3x is equal to 27x squared. And that 9x also has to be multiplied times that negative 2, which means it's going to be a negative 18x, right? And I'm going to just go ahead and subtract those now. And remember, this is these cancel out. 27 minus x squared, 27x squared minus 27x squared cancel out. But negative 3x minus a negative 18x is actually going to be negative 3 plus 18x essentially. And so that's going to be actually a positive 15x, right? So I get a positive 15x now. And I'm going to bring down my negative 10 term. When I do that, I start asking the question again. How many times does 3x go into 15x? And I get that 3x goes into 15x a total of 5 times. 5 times 3x is 15x, right? And 5 times a negative 2 is a negative 10. And I'm going to subtract those, and I think this is actually one of those ones that ends up being maybe a pretty one for us. Let me see if I did that right. Let me make sure I did that right. Let's see. 15. 5 times 3x is minus 15x. 5 times a negative 2 is a minus 10. Okay, so actually it's not a pretty one for us because it looked pretty for a second, but 15x minus 15x is in fact no problem. But then I have negative 10 minus a negative 10, which is actually, Mr. Sims, what did you do? All right, I think Mr. Sims made a mistake somewhere. I'm just trying to figure out where I made my mistake. So hold on a second. Oh, I wrote down the equation wrong. Here we go. No? Oh. Okay, yeah. So in this case here, yeah, it actually works out. Minus 10, and I should get, 9x squared plus 9x plus 5. And that's the final answer. Yeah, it actually does go in evenly. So I was looking at another problem earlier that actually had a little bit of a remainder, but that's not this problem because the last number here isn't the same. So anyway, okay. So that gives me 0 as my remainder, and that's a beautiful, beautiful, beautiful problem there. I love it. It's wonderful and beautiful in every way. So, okay, let's go ahead and move on to our next problem. Okay. Oh my. Woo! Now this one here, they were a little bit naughty. And the reason why they were a little bit naughty is you'll notice that we have to put our things once again under the division thing. But I want you to look at carefully at the degrees that are here. We have 1 to the first degree here, and then we have our second degree term over here, and then here we have our k, really our 0 degree term, right, our k to the 0. And you'll notice that they're not in order, are they? So before I can even do this problem, I need to rearrange all of this in a manner that's going to get me, that's going to put them in the right order. So what I'm going to do is I'm just going to erase those because that would bother me, and I'm going to take and start off with my k to the third since that's my highest degree, right? My next highest degree is a negative 4k squared. My next degree is a negative 30k. And then I have subtracting 18 from it. All right, so this now is the polynomial I have to work with. I've just arranged it for in its descending values of degrees, right? So right now I'm looking pretty good in this regard, and so I have to take and divide that by 3 plus k. But you know what? I don't like this being arranged like 3 plus k, so I'm actually going to make it k plus 3, right? And so when I do that now, I can see this is now looking more normal than this was looking, right? And so I ask myself just the normal question we've been asking. How many times does k go into k cubed? And I get k, it goes in a k squared number of times, right? So k squared times that gives me k cubed, right? Then I say how many times is, I multiply k squared times 3. And when I do that, I get plus a 3 k squared, right? And everything's lining up really pretty and nice now. I'm going to go ahead and subtract those two. And actually, why don't you try it from here? Just see if you can get it from here now that we've lined up everything all pretty like. So go ahead and do it. Hopefully you were able to go ahead and try it yourself and kind of figure out where you go from here. So I'm going to go ahead and let me see, just finish this problem. I got 4k squared minus 3k squared. That's going to actually be negative 7k squared, right? And I'm going to take and subtract from that a negative 30k because I want to bring that down, right? That's where I got that from. I just bringing that down. I'm sorry if that was unclear. And I'm going to start over the whole process again. How many times does k go into negative 7k squared? And the answer is it goes in negative 7k times, right? And that negative 7k now multiplies times that 3. Well, let me go ahead and do that first term. Negative 7k squared is negative 7k times k. And then I'm going to do negative 7 times 3, which is going to be a negative 21k, right? And remember, I'm subtracting all this. So these two subtracted cancel out because negative 7k squared minus a negative 7k squared is really the same as adding 7k squared, so these cancel out. And this I have negative 30k minus a negative 21, so that's really the same as adding 21, which gives me a negative 9k minus 18, right? Because I bring down my negative 18. And so when I do that, I get k. I ask myself again the question, how many times does k go into negative 9k? And I should get, it goes in negative 9 times. Negative 9 times k is negative 9k, right? Negative 9 times 3 is negative 27, right? And I subtract all this now, and I get the negative 9k minus the negative 9k cancels out. The negative 18 minus the negative 27 is really adding 27. So I'm going to get 9, a positive 9. That's my remainder. My remainder is a positive 9. But remember, what I really want to do now is get my my 9 as a fraction. So I'm going to take my 9 and divide it by my divisor. So it's going to become 9 over k plus 3. Okay? And that is my answer. K squared minus 7k minus 9 plus 9 over k plus 3, or 3 plus k, since you could rearrange it to 3 plus k, since that's kind of what we started with. But since I rearranged it to get this, I figured what the heck, I'd leave it like that, right? So anyway, hopefully that made sense to you. Hopefully you're getting these problems now. We do have a couple more. Then, like I said, we're going to continue to get more challenging in these problems, because I like to stretch you, right? If I can teach you problems that are harder than what you're going to likely see, or at least towards the hard end of what you're going to likely see, then nothing's going to surprise you as you're learning it, right? So let's go ahead and do this problem now. This one here, you'll notice that there's something wrong with it, right? So first of all, if you looked at the other one that we just did, you know what? I'm not going to tell you anything. I just want you to try it. Maybe you'll be successful. Go ahead and give it a shot. See if you can tackle it. All right. You know what? I hope you did it, and I hope you got it right. So let's just see if you did, right? Obviously, there are lots of pieces in this problem. This problem can be a little bit intimidating, because there's a lot of places that you could go wrong. In fact, heck, I might go wrong working it. You've seen me go wrong in problems before. Hopefully I catch it before too long here, but I'm going to take this and go ahead and just write it out the way that we've been doing it. So I have my 3x to the fourth minus 2. Well, I don't want to do minus 2 though, because I actually want to put them in the correct order. Now, here's the problem. I have an x to the 1. Remember, this is essentially my x to the 0 term, so I'm going to put that last. This is my x to the 1 term, but you'll notice I'm missing a couple terms in here. I'm missing a couple of degrees. So I'm also missing a 0 x to the third term plus a 0 x squared term. And then now I can finally get to the terms I actually do have. I got a minus 5x to the 1, right? And I also have a minus 2, right? I don't need to write the x to the 0. I could, but I'm not going to, because it's kind of pointless. And basically I end up with that here, and I'm going to divide that by my divisor, which is x squared minus 3x. So I'm going to once again do the same thing I've been doing. I'm going to ask myself the question, how many times does x squared go into 3x to the fourth? And hopefully, if you weren't able to get it from maybe here, you could pause the video and try and get it from here again, because at this point I think you do know these steps, right? So go ahead and try. All right, if you want, I'm going to go ahead and do it for you now. X squared goes into 3x to the fourth. First of all, to get this 3, I obviously need to multiply times 3, so I need to multiply 3, but I also need to get this x to the fourth term. So to do that, I need to get x squared. X squared times x squared is x to the fourth. So I end up with getting 3x to the fourth, right? And then I need to still multiply this 3x squared times my negative 3x. So when I do that, I'm going to get, let's see, 3x squared minus 3x. That's going to be a negative 9. X squared times x is going to be x cubed. Okay? And that's one of the reasons why it's so important to put these in, because now I have a space to put this. If I didn't have that in, I wouldn't have any space to put this negative 9x cubed, and then I wouldn't have anything to subtract it from, and it would just get really messy really quick, and it wouldn't work actually easily. So yeah, that'd be an interesting problem to try and figure out how to do that without putting these in, but I wouldn't suggest it. So all right, always put them in. Basically, always put it in. I'm just talking mathematically. It'd be fun to kind of figure it out. But anyway, always put them in. So here you get 3x to the fourth minus 9x cubed. Now I'm actually going to take and I'm going to subtract these. Once again, these cancel out. They won't always, but in this case they do. And I get 0x cubed minus a negative 9x cubed, which is going to really be plus 9x cubed. And so I just put that there. It's beautiful. And I'm going to bring down my 0x squared. So plus 0x squared term. Okay, and when I do that, now I ask the question once again, how many times does x squared go into 9x cubed? And the answer is it goes in 9 times. And I need to get this x cubed term, so I also need an x there, right? So 9x times x squared is equal to 9x cubed. But once again, I'm not just multiplying that 9x times x squared, I'm also multiplying it times negative 3x. So 9x times a negative 3x is going to be a minus 27x squared, right? And isn't that getting pretty? Yeah. So, all right, so now we have 9x minus 3x is a negative 27x squared. I'm going to go ahead and subtract those. And these cancel out once again. And in this case here, I get 0x squared minus a negative 27x squared, which is really just adding 27x squared. So I get 27x squared. All right, so at this point here, I'm going to bring down my negative 5x, right? And these problems are long, but at this point they're not too difficult, right? They're just kind of tedious, right? But that is unfortunately the nature of long division a lot of times. So just bear with it and just be very, very careful when you're doing it, and you should be fine. So x squared goes into 27x squared, a total of 27 times, right? 27 times x squared is 27x squared. And then I have to multiply my 27 times my negative 3. And oh my gosh, I don't even know what that is. I'd have to, well, actually, 60, 21, 81? That sounds about right. 81 sounds right. But you know what? Let me just check it just to make sure I don't want to lead you astray. So negative 3 times 27 is equal to negative 81. Yoo-hoo! So, all right. So I get 27 times the negative 3 is a negative 81. And that's a negative 81x, right? That is ugly, but cool. All right, I like it. So 27 times a negative 3x is a negative 81x. I go ahead and subtract that, right? And I get negative 5x minus a negative 81x is going to give me, once again, I'm be adding that then. So I really get a positive 81 minus 5. It would be positive 76. Is that right? So 76x. And then I'm going to bring down my negative 2, right? I don't like the way I wrote that. Let me do that again. Oh, I wanted that though. So minus 2, I bring down the negative 2. And I ask the question again, how many times does x squared go into, uh-oh. Now you'll notice here, I want to ask that question. But here's how you know you're done with long division. Just like in regular division, when you reached a point where your number was smaller than your divisor, and you kind of knew you were done, right? Here you have your, let me go back to explain what I meant by that. I'm sorry. So I knew I was done when I was kind of done with all these numbers here, but mostly because when I subtracted and there was nothing else to bring down, my 2 was smaller than my 3, right? And so I knew I was done. And it's similar actually here with this problem here. The reason that I know I'm done, the way I know I'm done is when my degree that I get here, when the degree of the polynomial that I get here, this is an x to the 1, when this is less than this, that's when I know I'm done. So in this case here, x squared, I can't divide x squared into this anymore because this is now smaller than x squared. So that's how you know you're done. When this degree gets smaller than this, I'm done. And you might be saying, well, what on earth do I do with this 76x minus 2? And that's a very valid question. What do you do with that? And so let me actually show you what you do with that. I'm actually getting rid of that because that's kind of annoying me. And so I take my 76x minus 2, and what I'm going to do is I'm going to put it on top just like I've been doing. So I get plus 76x minus 2 all over x squared minus 3x. And that's one way to deal with it, right? We basically just made it a fraction like we've been doing. And that right there is my final answer. And yes, it is ugly. I will grant you that, right? If they ask you just for the remainder or something like that, that's the remainder right there, right? But basically, I just wanted you to see that this is basically how you solve that problem. And once again, you know you're done because this degree is smaller than this degree, okay? So that was probably a little bit of a challenging problem, and maybe you got stuck once you reached here. If you paused the video and got stuck once you reached there, I commend you for making it through to there, and that's okay. We're going to figure out now some other fun stuff here. Let's see. I think you guys are starting to get this really well. I'm going to give you 2 challenge problems now. So, challenge problem number 1 coming up here. Here we go. All right, I want you to pause the video and give this a shot. Now, the only hint I'm going to give you is fractions. Yes, that's why it's a challenge problem. Challenge problem for the love of everyone. So, challenge problem, right? My baby girl loves challenge problems because they make your brain grow, and this is no exception. I want you to try this challenge problem, okay? So, go ahead and try this one, and then we'll go on to the next one after we solve this one. All right, hopefully you actually did try this challenge problem. It is kind of beastly just because it's got fractions, and I like it because fractions make people cry. And crying, let's face it, we can sell the tears on eBay. So you got 10n's, 2n's cubed plus 20n squared plus n, right? All that's going to go under my division sign. Yay! And I'm going to divide that by 10n squared. Now, when you first started this, you might have been like, oh, that's only just like one term, right? So that's going to be easy. I'm so glad you thought that. So, all right, so we asked the question, how do we get from 10 to 2? Now, to get from 10 to 2, I can't multiply by any just whole number, but what I can multiply it by is a fraction. If I get 1/5 times 10, I should get 10n squared, right? In other words, if I take 10, let me do it over here. If I take 10 and I multiply that times 1/5, I should get that 2 that I need, right? And then sure enough, 10 becomes 10 over 5, and 10 over 5 is equal to 2. So that gives me the 2 term I need. So that 1/5 is right. And now I say, what do I multiply n squared to get n cubed? And what I multiply that by is n. So I now get 1/5 n. And really the other way that I can write that, and I actually prefer to write it in general, is n over 5. So if you don't mind, you know what? I'll leave that like that for now. When I finish at the end, I'm going to make that n over 5. But we'll leave it as 1/5 n now. And now I'm going to say, how many times does 10n squared go into 20n squared? And if you were stuck at that step, but you think you kind of could figure it out, now go ahead and pause it and give it a shot, right? And then see if you can get the rest of it right. It's always fun to do that. But I'm just going to go ahead and continue. You can pause the video if you want to do that. 10n squared goes into 20n squared a total of 2 times, right? I don't need anything else, right? So 2 times 10n squared is equal to 20n squared. Oh, what am I doing, Mr. Sims? What are you doing? Mr. Sims, oh, no, I did right. I just needed to actually write down my stuff here. So 2n cubed is what I did end up with, right? And I subtract and I get 0. Then I bring down the 20n squared, right? Okay, now we're good. Okay, so now once again, I say, how many times does 10n squared go into 20n squared? I don't need to worry about this 0 because it's basically gone, right? So I go, it goes in 2 times. 2 times 10n squared is 20n squared, and I subtract and I get 0. And once again, I bring down the n, and I don't need to worry about that 0 because it's 0, right? 10n squared goes into n. At this point, really, in a way, I have a remainder, right? I guess I could leave it like that. But you know what? I have another thing I could do. You know what? Actually, let's just leave it a remainder. I don't want to confuse you guys. So then I end up with plus n that's over 10 n squared. But remember, you got to simplify this now. N over 10n squared is really going to be, remember, n divided by n squared would cancel out one of these n's, right? In other words, I have n over 10 times n times n, because that's really what n squared is, right? So one of these n's is going to cancel out, so I'm going to be left with 1 over 10n, right? I'm just going to put that here instead. My final answer ends up being 1/5 n, and I actually wanted to change that to n over 5, right? Plus 2 plus 1 over 10n. Yeah, wasn't that cool? So, all right, hopefully that wasn't too hard for you, but I did want you to see kind of how you do that, right? And once again, what probably made it difficult for you was the fractions, but really, in terms of everything else, it wasn't that bad. Let's go ahead and do another problem here. In case you didn't understand how I got the n over 5, I did that because 1/5 n, remember over here, I did, 1/5 times n over 1 is really going to just be equal n over 5. And that's why I made it n over 5, right? Because that's just neater. Here's the plus 2, and this once again simplified to 1 over 10n. I did that here, okay? So anyway, hopefully you understood that problem. Let's go ahead and now move on to my last problem of the night. I know you're like, Mr. Sims, can't we do more? Another time. So here we go. Last problem of the night. Go ahead and pause it and give this beast a shot. All right, hopefully you did pause it and you gave it a shot. And what you start off with is 3v cubed plus v squared plus 2v. And I'm going to take and I'm going to divide that by 9v cubed, okay? And that 9v cubed goes into v cubed how many times? Well, to go from 9 to 3, I really got to multiply it times 1/3, right? So I got to multiply it times 1/3. And in fact, I I can't multiply it times any v. If I multiply it times any other v, I'm going to get over this, right? So I get my 1/3. 1/3 times that is going to be 3v cubed. And I'm going to go ahead and subtract that, and I get 0. And here I have 0 plus v squared, right? And at this point here, I asked the question, how many times is 9v cubed? At this point, normally you would think, okay, I'm done. And you could be done here. You really could. I mean, you could have a remainder of v squared plus 2v, and you put that all over 9v cubed. You could do that, I suppose, right? But I'm just going to kind of work it out here for a second. I'm going to ask myself some critical questions and see if I could kind of figure out what to do here. So 9v cubed, if I wanted to get v squared, right? First of all, I would need to multiply it times 1/9, right? Because I got to get rid of that 9 here. And then my question is, how would I get v squared from 9v cubed? Well, I would actually have to get rid of one of the v's here. So when I multiply 9v cubed, I would have to multiply 9v cubed not only times 1 over 9, but I would actually have to multiply 9v cubed times 1 over 9v, because that v is going to cancel out with that v cubed then. And that's going to give me that v squared that I need. So I could actually take and make this v squared. Sorry, did I say that? No, I did not do it right. Sorry, 9 over v. Does that make sense? So in other words, 1 over 9 times 1 over v. Because 1 over v is going to be that, but I would actually combine these two here, and I'm going to get 1 over 9v. Because if I take my 1 over 9v and I multiply it times this, my 1 over 9 is going to cancel out this 9, and my 1 over v is going to cancel out my v cubed to get v squared. And so when I do that, actually, I could take and I could strike. If this one is really confusing you, then listen, don't just ignore it. All right, this, like I said, is a challenge problem, and I just wanted you to see that it can get pretty crazy, right? But it also can be crazy fun. This is kind of just to stretch your brain a little bit, right? And then I'm going to go ahead and take my 2v here and bring it down. I once again could ask myself the question, what do I multiply 9v cubed to get 2v here? Well, if I wanted to get 2v, I want to get 2. So what do I do to 9 to get 2? Well, to get 2, I would actually need to multiply it times 2 over 9, right? If I multiply it times 2 over 9, isn't that going to give me 2? Yeah, because the 9s are going to cancel out, right? And I get 2. So in this case here, I know I have to multiply it times 2 over 9. but I also have to take, and I have to get this v here. So that 2 over 9, I actually have to put my v over, I have to get that v by getting 2 v's away from this v cubed. So the way I would do that is by putting it over v squared, right? In other words, if I have 2 over 9v squared and I multiply that times 9v cubed, right? My 9's are going to cancel out, and my v squared is going to cancel out 2 of my v's, right? If you want to see that happen, I get 2 over v times v times v times v times v, right? On this side, and so 2 of these cancel out with 2 of these, and I get 2v, right? Makes sense, which is what I wanted to get here. So 2 plus 2 over 9v squared. And so hopefully that made some sense to you. If it didn't, I'm sorry, I don't want to confuse you with this one, but like I said, it is a challenge problem. Basically, I just want you to know, if you could do all the way up to here, you're going to be fine for basically most of algebra, at least algebra 1. And so really, if you're good with this, man, you're really set. So anyway, I just want you to backtrack now to what did we start with. Remember, we started with this back in 5th grade, and we just used that process now to do some really cool stuff. Remember, it is the opposite of FOIL, right? So you can always check your answer by doing FOIL then. But we just got some pretty stuff here by doing this one here, where we started off, we got nice remainders of 0, but those quickly went away, and we started getting some problems that didn't have nice remainders of 0, and you had to start putting it over the divisor to get it right. And then finally we came over here, and we once again we got the 9, and you had to put it over the divisor, and I explained to you how you would actually practice, do the FOIL and add that 9 in the end if you wanted to check yourself, right? I explained over here how once again we did that same thing, right? But eventually we got to things that are where you're missing terms. This is not the one where you're missing terms. This is the one. Here's the one where you're actually not missing terms, but the terms are jumbled, right? And so you had to learn to rearrange these terms in the right way. Then we went over here, and you had to learn to put in terms that didn't exist. If the degree of the term didn't exist, you had to learn when to deal with that. And finally, we got to the challenge problems here where you even learned how to deal with it with fractions, all right? Anyway, I just want you to know that you are capable of so much. Honestly, if you did this, I just want to commend you once again, as always, for just taking that step in your learning and saying, you know what, I'm going to be a learner myself. I'm going to be an amazing student who just is able to learn on their own. And as I always tell you, you don't need Mr. Sims. It's nice to have me, I think, but you don't need me. And really, whether it was my videos or some other videos, you can teach yourself, because that is just how amazing you are. So if you ever need help, don't hesitate to ask me. But if you ever need help, a lot of times you'll be able to figure it out on your own if you just give that brain a shot, because you have an amazing brain. So once again, I commend you for your hard work. I commend you for all you've done. You're an amazing kid, an amazing student, and I just want to wish you the very best in this rest of the year in algebra. I wish you the very best, and have a wonderful, wonderful, wonderful day/night, whichever one it is when you're watching this. And have a great one, and I'll see you soon.